Hey everyone, so this is the first lesson where you're going to watch the video online and take notes at your own pace. For this lesson, you're going to need a notebook and a pencil. Throughout the lesson, I'm going to tell you when is a good time to pause and to write things down, and then to answer any questions that I have on the slide. So, we're looking at variables and expressions. A variable is a symbol that represents one or more numbers. So, they're all lowercase, so G, Y, A, X are all examples of variables. An algebraic expression is a mathematical phrase that contains numbers, variables, and operation symbols. So, I gave you an example, 13 minus G, or you could have 15B. Those are variable expressions, or an algebraic expression. Now would be a good time to pause, write down the vocabulary, and then press play when you're ready. There are two types of expressions, a numerical expression and a variable expression. A numerical expression is a mathematical phrase that contains numbers. So for example, 5 minus 5. There's no variables in that expression. A variable expression is a mathematical phrase that uses variables and numbers. For example, C minus 5. It has a variable and it has a number. If you notice, expressions do not have equal signs. So let's practice identifying whether these expressions are numerical or variable. So let's do the first one together. 8 divided by X. If you notice, there's a variable, so this would be a variable expression. And we need to define the variable, which would be the letter X. I want you to try all three of these on your own. Take note on this one. This is the multiplication sign, and we're going to talk about this when we come back. So now is a good time to pause and write these answers down in your notes. So let's take a look at how you did. D plus 43 minus 9. This is a variable expression because it contains the variable D. 100 times 6. This is numerical. However, I want you to put a star next to this because you will not be seeing the multiplication signs used with the X because that looks like a variable. It could be the letter X. If you put variable and put X as your variable, I would also accept that. You're going to see multiplication represented with a dot, so 100 times 6, or you may even see it represented with parentheses. The letter X, or the times sign, will not be used when we're looking at expression. It can be, but might not be. 16 plus 4, there's no variables, so it's a numerical expression. So there's a lot of words going on this page, and this is a very helpful chart that I advise that you would copy down in your note. So we're looking at word phrases and how they relate to algebraic expression, and I broke it down to addition, subtraction, multiplication, and division. So what this shows you is the different word phrases that you can use to represent this expression. So for addition, the common words that you can use are plus, sum, more than, and increased by. I want you to put a star next to more than, and write, when you use this, you flip the order. What do I mean by this? So let's look here. We have M plus 45. The M comes first, then the 45. Well, when I read this phrase, 45 more than M, 45 is second, and the M is first. We flip the order when we use the phrase more than. It's important to remember that. There's going to be a couple others that I have you put a star next to as well. Subtraction. P minus 6. The difference of P and 6. 6 subtracted from P and 6 less than P. Take a second to look at all the representation for subtraction. Which one look like we're going to flip the order? subtracted from, we're going to flip the order. 6 subtracted from P, we're taking 6 away from P. 6 less than P, we're taking 6 less than the variable P. I also want you to add another one. Fewer than. I would say 6 fewer than P. So let's take a look at multiplication. We have 4 times K and the product of 4 and a number. Notice the number always goes before the variable. Make sure you put it before the variable. You're never going to see it written like this. The number always comes first. So last one, division, the quotient of Z and 25, and Z divided by 25. And you can also use the fraction bar, so Z divided by 25. So I want you to take a minute, hit pause, and make sure you write down all the information on the slide. So let's practice writing algebraic expression. So you're going to use that chart that you copied down. So the key to writing algebraic expressions is you want to identify the important words. So 7 more than n. More than is our keywords here that we're going to go back, look at your chart, and you'll see more than means we're dealing with addition. More than was one of the ones we put a star next to. So we have n plus 7. 7 more than n, because this is the one that we flipped. The difference of n and 7. So again, identify what the common word is, or the important word is, and that's the difference. Difference means subtraction. N minus 7, because it's not one of the ones we need to flip. The product of n and 7. So take a second to identify the important word there. Product, so we're dealing with multiplication. Again, we always put the number and then the variable. So 7 times n, 7n. So I want you to look at these and try them on your own. Make sure you write down the example and then your answer so that you can go back and look at it later. You have the phrase that you were translating into an algebraic expression. So let's look at how you did. So a temperature of T degrees increased by 5. So notice I underlined the important words increased by. So I knew I was looking at addition. So T plus 5. 5 cats fewer than C cat. Well, I know that fewer than is one of the ones that we flipped, so C minus 5. The product of 5 and n nickels. The product means multiply, so 5 times n. Always put the number first. A dinner bill of D dollars divided among 5 friends. So D divided by 5, or you can use the fraction bar. Try 2 more on your own. So again, now would be a good time to press pause. So here are the answers that you should have written on your paper. Again, you can use the fraction bar or the division sign to represent quotient, and less than is one of the ones that you need to flip. So writing word phrases. So again, that chart that you wrote down will be helpful when you need to write word phrases. So here I have the expression, x plus 2. Well, that's one of the phrases that I can use to write, to describe this expression, x plus 2. Another one would be x increased by 2. Or I could even say 2 more than x. Remembering that the more than is the one that I need to flip. So why don't you go ahead and pick 2 and write 2 phrases for each of these expressions. So here's some answers that you may have written down. They should look very similar, and they should correlate with the chart that you wrote down in your note. So 5 plus n more than 5, p divided by 3, the quotient of p and 3, c minus 50, or 50 less than c. So let's take a look when we have a two-step. So now we need to remember that it's very important to identify what operations we are using in our algebraic expression. And we also need to define our variable. So here we have 2 times a number plus 5. So I know I see one operation, which is times, and I see another operation, which is plus. So I need to ask myself first, are any of these terms the ones where we flip? And they are. So now I need to say, what does times mean? Well, I know I'm going to be multiplied. So 2 times a number. I don't know what a number is. So I'm just going to use the letter n and say this represents a number. So I've defined my variable. So I have 2 times a number n plus 5. So I've identified the operations that we're using. Ask myself if either of these are the ones that we flip the order, and then I define my variable. So let's look at this one. 7 less than 3 times a number. Less than and times is what we're looking at here. Less than is one of the ones where I have to flip, which means that this part of the phrase is going to go first. So 3 times a number. So again, I can have n equal a number. So 3 times a number, less than means subtraction, and then the number 7. Go ahead and try this one on your own. So you should have noticed that this is a single step expression. So it just has less than, which is one of the ones we flip. So 9 less than a number, so n minus 9. And I identified what my variable is. I defined it. It's very important that you define your variable. Let's look at these two. The sum of twice a number and 31. So we have keywords sum and twice a number. Twice means we're going to multiply it if I'm doubling something. So I have 2 operations here. Neither one of them mean that I have to flip the order. So I have the sum of twice the number and 31. So again, n equals a number, twice the number, 2 times the number, I'm doubling it, plus 31. The total cost of cans times 70 cents. So go ahead and try this one on your own. So you should have gotten 70 cents times C. Again, we always put the number before the variable, and we define our variable where C is the total number of cans. Go ahead and try these two on your own. Here's what you should have gotten for both these expressions. 10 more than twice the number x. Again, more than is the one we flipped. So 2x plus 10. And 9 and 8500 less than the product of t and 37. 37t minus 9 and 8500. So this one says the total length of a rope in feet used to put up tents is 60 times the number of tents. So I have to ask myself, do I know how many tents there are? No. So I would just use 60 times the number of tents, which we don't know. So 2 is the number of tents. So I define my variable. Go ahead and try to find the total cost is the number of sandwiches times $3.50. Represent this with an expression. So for this, you should have had $3.50 times S to S is the number of sandwiches that you have. So for these last two problems, we have a table. So what we need to do is define a variable and write an expression to model the relationship. So here I have the number of workers and how that relates to the number of radios built. So for one worker, 13 radios are built. For two workers, 26 radios are built. For three workers, 39 radios are built. And for four workers, 52 radios are built. So, knowing that one worker is going to make 13 radios, I know that that's going to affect my expression somehow. So based upon the number of workers, and knowing one worker can make 13, I'm going to take how many workers I have and do what operation to the number 13. Take a second to think about that. 13 times the number of workers is how we can represent this table. So let's look at this one. The number of sales and the total earnings. So how does the number of sales affect the total earnings? So let's use S to be the number of sales. What do I do to each number of sales to get my total earnings? So take a second and think about that. So you should have discovered that 40 cents times the number of sales will give us our total earnings. So that's it for this lesson. So you need to make sure you took notes, go back if you need to, write things down, put a star next to any questions that you may have. Go to the website and you need to click on the link to answer the questions. And remember, these are not graded, it's just a completion. So you need to do this quiz before you come back to class. If you have any questions, let me know. Thanks.